So this is the 2017 Leaving Cert Ordinary Level Paper 1, and we're looking at question number 2. Part A, the complex number z1 is equal to a plus bi, where I squared is equal to -1. And this is shown on the Argand diagram. So here's z1. And they want us to write down the value of a and the value of b. So in other words, what's the name of this complex number? Well, it's over 3 on the real axis and -1 on the I-axis. So it's 3 minus 1i. So your a value is 3 and your b value is -1. B is just a number in front of I, so it's not -1i, it's just -1. Part 2, z2 is equal to -1 plus 2i, and you have to plot this in the Argand diagram. So starting at the origin, we go -1 on the real, and then plus 2 on the imaginary. We end up here, and always label those coordinates, always label them. So that's z2. Part 3 then says z3 is equal to z1 over z2. Write z3 in the form x plus yi. So in other words, find out what z3, the complex number z3. Okay, well z3 is equal to z1 over z2. So remember, z1 was 3 minus 1i. All over z2, which is -1 plus 2i. -1 plus 2i. Okay, now, so what we have, z3 is equal to one complex number over another, or one complex number divided by another. So when we're dividing complex numbers, remember, you multiply above and below by the conjugate of the bottom. So the conjugate of the bottom would be, conjugate at the bottom is -1 minus 2i, -1 minus 2i. And you're going to multiply the top by the very same thing, -1 minus 2i. So that's how we deal with the division of complex numbers. We multiply above and below by the conjugate of the bottom. And remember, the conjugate is where you change the sign of the imaginary component, not the real bit. So plus 2i changes to -2i, nothing else. Okay, so I've shown that in a different color because that's kind of what we're adding in. And now I'm just going to multiply these out. So to multiply the top, so you can do these separately if you like and bring them back at the end. I'll do it that way. So 3 minus 1i multiplied by -1 minus 2i. I'll do the top there. And then I'll do the bottom, -1 plus 2i times -1 minus 2i over here. Okay, so 3 by -1 is -3. 3 times -2i is -6i. And then -1i by -1 is plus 1i. Careful there. And -1i by -2i is plus 2i squared. Okay, so now we're going to try and tidy up. Remember, you're going to combine the i's and you're going to change the I squared to -1. Remember, the question started by saying I squared is -1. So anywhere you see I squared, we always change that. So this then becomes -3. I'm going to leave that. I'll combine these two i's, -6i plus 1i, that's -5i. And then here we have plus 2, and replacing the I squared with -1, because that's what it is. So that becomes -3 minus 5i, plus 2 by -1 is -2. And then finally, we're just going to combine the -3 and the -2 together. That'll give me -5. And then the -5i remains. So that's the top bit sorted, the top. So now we're going to do the bottom. Now remember, the whole point that we multiply a complex number by its conjugate on the bottom is so that the I components disappear. So we're expecting the I bits to disappear here. So let's see, does it happen? So -1 times -1 is 1, minus by minus. -1 by -2i is plus 2i. Okay, and then we're going to do these two. Plus 2i by minus 1 is minus 2i, and plus 2i by minus 2i is minus 4i squared. Okay, so what have we got? Well, we've got the 1. Here we've got the minus 2i plus 2i. They combine to give nothing, 0. And you've got your minus 4i squared, which we're going to write as minus 4 by minus 1, because I squared is minus 1. And then that becomes 1. Minus 4 by minus 1 is plus 4. And 1 plus 4 is 5. So now I'm just going to combine these two back together. Put the bottom over the bottom under the top over the bottom. So this was the top bit here. So you've got minus 5 minus 5i all over 5. Okay, so we can simplify this because we can divide everything by 5. So 5 into 5 goes once, 5 into minus 5 goes minus 1, and 5 into minus 5i goes minus 1i. So the answer then is minus 1 minus 1i, or minus 1 minus I if you like. And that is in the form x plus yi, where x and y are real numbers. So minus 1 and minus 1 are real numbers. Okay, finally, part B. Solve for z. Okay, so we've got i's and z's here, but we're only interested in finding the value of z. Okay, so we need to isolate z on its own. We're going to finish up at the end with z equals something. Okay, and we're expecting probably a complex number, maybe. So there may be i's in our answer, which is fine. Okay, so let's see. Okay, so first of all, I suppose we can multiply the minus 6 by both of these. And be careful there, this is not 2z minus 6 in a bracket where you multiply everything by everything. It's the 2z is on its own, we're just multiplying this out. And then over here I can do my multiplication as well, the minus 1 by both of them, and also the I by both of them. So I can start with that. So I'll leave my 2z alone. Okay, minus 6 by 4 is minus 24. Minus 6 by minus 6i is plus 36i. Okay, and that's equal to minus 1 by 4 is minus 4. Minus 1 by minus 2i is plus 2i. I by 4 is 4i. And I by minus 2i is minus 2i squared. Okay, so some tidying up to do and some moving around. Let's see. I'll tidy up the right first. Okay, so minus 4, 2i, and 4i, that's 6i. And minus 2i squared, well that's minus 2i minus 1. So that's minus 4 plus 6i. Minus 2 by minus 1 is plus 2, which is minus 4 and 2. You can combine those two, the minus 4 and the 2. That'll give me minus 2 plus 6i. So that's the right sorted. So then over here, this can stay the same all the way down. So I suppose here you've got 2z minus 24 plus 36i. And you can bring both of these, bring this over here, it becomes plus 24. And you can bring this over here, and that will become minus 36i. So you can combine them with these components then. So you've still got 2z on the left equal to 24 minus 2 is 22. 6 minus 36 is minus 30i. So 2z is 22 minus 30i. Well, that means z, divide both sides by 2. Divide everything by 2. They cancel, leaving you with z. And z is equal to 22 over 2 is 11, minus 30 over 2 is 15i. So there's my answer for z, and that's the end of the question.